All right, good morning, fifth graders, or good afternoon, or good evening. This is lesson 13, problem set. We are working right now on finding the area of rectangles, but we have to multiply improper fractions and mixed numbers to get the area. So let's just get right started on it. We're going to start with A. 5/5 kilometers times 12/5 kilometers. I'm going to go ahead and I'm going to show you two different ways to do this, and you're going to ultimately pick the one that is the easiest for you and makes the most sense. But right now I want you to set this up with me. I'm going to draw my rectangle for area model. I have 5/4, and I'm going to go ahead and I'm going to draw 5 parts because each of those are worth 1/4. And then I am going to put 12/5 up here. I'm going to draw 12 parts. Each of those are 1/5. Perfect. Now I'm going to set up my multiplication. 5. I'm just going to erase that. 5/4 times 12/5, and here's a second way you can do it. Now either you can count all of those chunks, and if you counted that you would get 60. You can also multiply 5 times 12 to get 60. Multiply straight across. 60 is the amount of total pieces, and the amount of pieces that make one whole is what is shown in our denominator by 4 times 5. And 4 times 5 is 20. Now I need to simplify that. I don't know how many times necessarily 20 goes into 60, but I know how many times 2 goes into 6, and then it's 3. So the answer is 3 kilometers, and we need to remember, since we're dealing with area, 2-dimensional squared. You can circle that. Not so bad, right? Now I'm going to erase that. I'm going to get started on this next one. So you can stay right with me. Good job, you guys. All right. 16 1/2 times 4 1/5. Now, the different thing about this problem is we are now going to have to make it into an improper fraction from the mixed number, because it's not already set up like that with us, like the other one was. So I have 16 1/2 to make that into a improper fraction. I'm going to have to multiply the whole number by the denominator and add the numerator. So 16 times 12 is 32. Plus 1 is 33. So I have 33 halves, or 33 over 2. And then 4 times 5 is 20, plus 1 is 21 fifths. So 21 fifths times 33 halves. Now, I'm just going to have to multiply straight across. If you choose, you can set up the area model. It is going to be a lot of chunks, but 21 over 21 fifths, 33 halves. You have to draw 33 pieces and 21 pieces this way and count them all up. That is up to you. I'm going to go ahead and I'm going to multiply 21 times 33. I'm going to multiply it here. Hopefully I can challenge you to do it on your own and just check your work against mine when you're done. All right, great job. We got 693. 5 times 2 is 10. 693 over 10. Now, let's divide that out so we can simplify that, because I don't know about you, but I cannot do that in my head. All right, how many times does 10 go into 6? Remember, when we're multiplying, we're dividing by 2-digit numbers, we cannot just take each number alone. We need to divide them together. So how many times does 10 go into 6? 0. How many times does 10 go into 69? You think about it. 6. And divide that and subtract 60. 9. Bring the 3 down. How many times does 10 go into 93? 9. Subtract 90. Now, remainder is 3, but it's not going to be a remainder. It's going to be a fraction. So I have 69 and 3 tenths. But don't forget your unit. Wow, that was cool. Don't forget your unit. It is meters, and not just meters, meters squared. Perfect job, you guys. I'm going to erase all this work here. Now, that seemed like a lot of work, but remember, all that we're doing is we are making our numbers into improper fractions. We are multiplying across, we're using our area model, and then we are simplifying and remembering our units. Those are the steps right there if you want to write those down to remember. I'm going to let you do problem C and D on your own, but I want you to remember while you're doing those that we do need to change those into improper fractions or fractions greater than 1, except for the 7/8, which is already in a fraction form. And we do need to remember our unit. You can use the area model if that works for you. Let's go ahead and do number 2 together. Julie is cutting rectangles out of fabric to make a quilt. If the rectangles are 2 3/5 inches wide and 3 2/3 inches long, what is the area of 4 such rectangles? All right, let's set this up. An important thing that we're going to need to remember is this 4 such rectangles. I'm going to try not to forget about that. And looking for my important numbers, I also see 2 3/5 inches, 3 2/3 inches, and I'm trying to find the area for such rectangles. All right, now you can set up your area model if it's the method you choose to do. Otherwise, we need to make 2 3/5 inches and 3 2/3 inches into improper fractions. So 2 times 5 is 10 plus 3 is 13. So I've got 13/5. And then 3 times 3 is 9 plus 2 is 11/3. All right, let's do this. Now I have to do 13 times 11. I'm going to do that along here. You can do it alongside. See if you can do it faster than I can. $143.15. All right, now I am going to divide because I cannot do that in my head. How many times does 15 go into 1? 0 times. How many times does 15 go to 14? 0 times. How many times does 15 go into 143? Now I'm going to set this up, and I'm going to have to multiply and try it out. I know that 15 would be, 15 times 10 would be a little bit too much at 150, so I'm going to try 9 and see if that works for me. Remember, you can just test it out. You can guess a number, and as long as you multiply and see what the value really is. All right, so 9 is 135. Is 9, and not remainder 8, but 8/15. Good job. That is the answer. And 9 8/15, but we're not done. Our unit is inches cubed, and we're still not done because that's the value of one of the rectangles. Now we need to figure out the value of 4 such rectangles. I'm going to erase a little bit so I have some room to do that. But I want you to think a second about how we can figure out if we have the value of 1 rectangle, how we can figure out what the value of 4 such rectangles are. When it says such, it means they're all worth the same. Good. So I have 9 8/15 times 4. Now I need to make this into an improper fraction so that I can multiply. So 9 times 15 . $135 plus 8 is 143. We really could have kept it in this form when we had it down here. So I have 143/15 times 4. And remember, every time we have a fraction, it can always, as a whole number, it can always be 4 over 1. So the bottom denominator is 15 times 1 is 15. 143 times 4, that's big. We're going to have to write that out. 572 over 15. Now, I'm gonna need some more room. We're gonna have to divide that to make that into a mixed number again. Let's do that. This is a lot of work for this one problem, but you know what, we can do it. All right, how many times does 15 go into 5? We can't do that, 0, right? How many times 15 go into 57? Well, let's try 15 times 3. Okay, let's try 15 times 5. That's too much. So it's 45, so it's 3 times. 12. 122. I know 15 times 10 would be too much. So let's try 50. Does it be 150? Let's try 15 times 8. Okay, perfect. 38, and not just 2, but 2 15ths. That is our answer. What is the area of 4 such rectangles? 38 and 2/15 inches squared. Circle that. Give yourself a pat on the back. That was a lot of work. Erase that. And there's just one problem left. Let's go down and look at that. I'm going to let you do this one mostly on your own because this is a challenge problem and I think that you are up to it, but I want to walk you through it a little bit before you get started on that on your own. Mr. Howard's pool is connected to his pool house by a sidewalk as shown. He wants to buy sod for the lawn shown in gray. How much sod does he need to buy? Now, we know that he needs to buy sod for everything that is shown in gray. So we know initially that we can figure out the whole box by doing 24.5 times 24.5. Good. And once we are done, and once you multiply that, first you need to make it into improper fractions. Multiply, simplify. Once you've done that, then you need to subtract the parts that are in white. You already know the area of the pool house. You need to figure out the area of the pool and of this sidewalk here. You have enough information to do all of that, so you're going to need to find this area, subtract all 3 of those. It's going to be a lot of work, but I know you're up to the challenge. Good work today, you guys.